Well, howdy students, this is going to be Unit 9, Bonding Part 3, and the last two videos, the first one we talked about valence electrons and the octet rule, and the second video we looked at ionic bonds and how the Lewis dot structures look when electrons are transferred from a cation to an anion. And then we finished the last video talking about properties of ionic bonds. Today we're going to talk about metallic bonds, and we're going to talk about the properties of those metallic bonds. So metallic bonds consist of an attraction of freely floating valence electrons with a positively charged metal ion. So let me go back to the first page. Look at this image on the left. We have a bunch of positively charged cations, because most of the time metals form cations. And then we have this stream of pink floating around, and that pink is going to represent electrons. And what we'll find in metallic bonding is that the electrons can freely flow between the metal cations, and this is how they are able to stick together. So we have freely floating valence electrons, and we are freely flowing over the metal ions, which we call cations. These forces are what hold the metals together. So here's another image, and if we were to draw a picture or add something, we would see that these were all positively charged cations. And the red would be the freely floating valence electrons. So, because we have freely floating electrons, this makes metals a good conductor of electricity. Also a good conductor of heat. The heat and the electricity can pass freely through the nuclei of different metal ions. Ductile. We can bend metals and shape them into different forms because the cations can be shaped. Malleable kind of fits along with ductile. Malleable is the property to be hammered or flattened out into sheets. This can also be bent more easily, like aluminum foil. Tin sheets can also be bent fairly easily as well. So these are all properties of metallic compounds. Metals actually do form crystal-like structures. We call them crystalline forms. And there are three main forms that we want you guys to be aware of. So metals and ionic compounds are both in compact orderly patterns. Ionic compounds give more pretty crystals like quartz and silicone-based ionic compounds like diamonds. Identically sized spheres have several arrangements. We have three. Here they are. Simple cubic is the first, body-centered cubic, and face-centered cubic. So we're not going to ask that you draw these. What we're going to ask is that you are aware of them and can identify them. So there are three different types of structures. And here they are. So based on the name, simple cubic, body-centered cubic, and face-centered cubic. Well, the one on the far left is going to be simple cubic. If we have a cube, on each corner, each vertex, we have a metal cation. And because there's no other ions in this shape, in this structure, it forms a simple cube. Now the next one, we call it body-centered. Some people call it body-centered simple cubic or just body-centered cubic. We have one on each vertex. But then you'll notice we have one, guess where? In the center of the cube's body, which is why we call it body-centered. And then the last one, we have face-centered. We still have our cube structure, and this one looks the most complex. But if you look closely, you'll notice that there is one on each face of the cube. And so we're adding 6 ions around the faces of the cube, and there's nothing in the center. So we call this a face-centered cubic. And these are the three main forms of crystals in metallic structures. Sometimes we can actually combine 2 or more. So in the last example, we were talking about aluminum foil sheets which is just made up of aluminum, or tin sheets, which is just made up of the element tin. But sometimes we can actually combine two or more different metals into what we call alloys. Steels are most important alloys that we know of today, although there are many, many, many others. Steel has a mixture of iron, carbon, and you can have lots of different other elements that do different things. There's a video posted in Schoology that goes over several different alloys and what they combine and the different properties of those alloys. Other ones that you may recognize would be brass. Steel was mentioned. 14-karat gold, which is not pure gold. Sterling silver, which is not quite pure silver. And cast iron, which not quite iron completely. On the next image, you'll see a few others that I've included here. Ones that you may recognize: brass, bronze, cast iron. You may recognize pewter, solder, which is used for welding, steel, sterling silver, and maybe you've heard of white gold too. And of course, there's all kinds of other ones as well.